Integral of 0 to pi by 2 cos x divided by 2 minus sin 2x dx. Now how to solve this integral? For that we'll just apply the first property. The property says 0 to a f of x dx equals to 0 to a f of a minus x dx. So let us say this is equal to I. Then we can say that I equals to 0 to pi by 2 cos x divided by 2 minus sin 2x dx. According to the property, we can write it as 0 to pi by 2 cos of pi by 2 minus x dx divided by 2 minus sin 2 types of pi by 2 minus x, which is equal to 0 to pi by 2 sin x divided by sin pi minus 2x is sin 2x only. So the denominator will remain the same. The numerator changes to from cos x to sin x. Now let us add both of them. We will get 2y equals to, we are adding this one and this one. Both are equals to I. 2y equals to 0 to pi by 2 sin x plus cos x divided by 2 minus sin 2x. Now our focus should be what function will give me derivative as sin x plus cos x. So let's write down. We want to get sin x plus cos x dx equals to dt. What should be our t then? Sin x plus cos x we want to get. So shall we say sin x minus cos x? What happens? Let us see. Sin x derivative will be cos x. And cos x derivative is minus sin x. We have minus of minus. So this will perfectly fit into it. Now, our focus should be how to write 2 minus sin 2x in terms of t. That is 1 plus 1 minus 2 sin x cos x, which is equal to 1 plus sin square x plus cos square x minus 2 sin x cos x. And that can be written as 1 plus sin x minus cos x whole square. So we are successfully able to get our denominator in terms of t. Now we can go ahead and change it. We'll change the boundaries also. Sin x minus cos x equals to t. X equals to 0. Then t will be sin 0 minus cos 0 minus 1. X equals to pi by 2. Then t will be sin 90 minus cos 90. That is 1. So this is becoming minus 1 to 1. 2i equals to minus 1 to 1. dt divided by 1 plus t square. That is what we got. And we know this is a standard integral, so we can write down 2I equals to integral of dt by 1 plus t square is tan inverse t, and the boundaries will be 1 to minus 1. That will give us 2I equals to tan inverse 1 minus tan inverse of minus 1. 2I equals to pi by 4 minus pi by 4, that is equal to pi by 2. Therefore, I equals to pi by 4. So the answer is integral is pi by 4. Let's have a recap of this. We have been asked to find the integral of 0 to pi by 2 cos x by 2 minus sin 2x. So we applied the property that 0 to a f of x dx is 0 to a f of a minus x dx. From that we got 0 to pi by 2 sin x by 2 minus sin 2x equal to I. So only the numerator changed from cos x to sin x. Denominator remain the same. Adding them, we will get 2I equals to 0 to pi by 2 sin x plus cos x by 2 minus sin 2x. Now, we tried to get sin x plus cos x as a derivative, then we understood the function should be sin x minus cos x. So I went to the denominator and transformed that in terms of t, written it in terms of t. 2 minus sin 2x can be written as 1 plus sin x minus cos x whole square or 1 plus t square. So the integral now became 2I equals to minus 1 to 1 dt by 1 plus t square. 1 by 1 plus t square integral is tan inverse t. We supplied the boundaries, we got I equals to pi by 4.